Welcome to The Universe Next Door, the podcast where we explore the vast and intriguing world of parallel possibilities. Today, we'll be diving into the realm of speculative fiction and alternate realities with our special guest. So grab your quantum glasses and get ready for a mind bending journey through the multiverse. Today's journey starts with an intriguing question. What if our universe is just one of countless others? The multiverse theory suggests just that, and it's not just science fiction anymore. Astra, could you give us a brief overview of the scientific basis for the multiverse theory?
Absolutely, Luna. The idea of the multiverse connects deeply with quantum mechanics and cosmology. One of the most compelling pieces of evidence comes from the concept of cosmic inflation, suggesting that the rapid expansion of the universe after the Big Bang could lead to the creation of multiple, possibly infinite, universes within a vast cosmic landscape. Each universe could have its own set of physical laws and constants.
It's fascinating to see how this concept is mirrored in literature and film. From Philip K. Dick to Doctor Who, creators have been exploring parallel universes long before they became a serious scientific inquiry. These stories challenge our understanding of reality and identity, presenting a universe where everything is possible and every choice leads to a new world. It's that intersection between science and fiction that really opens up the philosophical implications of the multiverse. If there are infinite versions of us making different choices, what does that say about free will and destiny?
That's a profound question, Luna. From a quantum perspective, some interpretations suggest that every decision we make branches off into a new universe. This idea, while speculative, raises questions about determinism and the nature of reality. It challenges the notion of a single, unchanging universe and suggests a more fluid, dynamic cosmos.
And it's not just philosophy and science that are impacted. The idea of a multiverse has profound implications for our understanding of the self. In narratives, characters often encounter their other selves, confronting their choices and imagining different lives. This mirrors our own human experience of wondering, what if? These explorations, whether through scientific inquiry or speculative fiction, encourage us to ponder the mysteries of existence and our place in the cosmos. As we continue to unravel the secrets of the universe, who knows what other possibilities we might uncover? Speaking of possibilities and alternate realities, let's pivot slightly to a fascinating phenomenon closely related to the topic of parallel universes: the Mandela effect. It's where large groups of people remember an event or detail differently than how it actually occurred. Orion, could you share some popular examples of the Mandela effect that have captured the public's imagination? Absolutely, Luna. One classic example is the collective memory some people have of Nelson Mandela dying in prison in the 1980s, despite the fact he actually passed away in 2013, a free man. Another widely discussed example is the Berenstain Bears conundrum, where a significant number of people recall the name of the children's book series being spelled as Berenstein with an E rather than Berenstain with an A.
It's intriguing to think about these discrepancies in collective memory from a scientific perspective. While it's tempting to attribute these phenomena to the existence of parallel universes intersecting with our own, it's more likely explained by the fallibility and suggestibility of human memory. Our brains often fill in gaps or make corrections based on what seems logical or familiar to us.
That's a very important distinction, Astra. While the Mandela effect is often cited as evidence of alternate realities, it also underscores how our perceptions and memories aren't always accurate reflections of the truth. How do you think this affects our understanding of history and personal identity? It definitely adds a layer of complexity to our narrative as a culture and as individuals. These collective misrememberings can alter the way we view historical events and even how we see ourselves. Fiction often explores this, presenting characters who grapple with the truths of their own histories and identities, much like we do when faced with evidence that contradicts our memories.
Yes, and it raises questions about the reliability of collective memory in documenting historical events. If we can misremember something as simple as the spelling of a book series, What does that say about our recollection of more significant, complex events? This phenomenon could have implications for understanding our past and the way we construct narratives about our world.
It's a fascinating intersection between the physics of the universe, the psychology of memory, and the construction of history. As we delve deeper into the Mandela effect and its implications, we're reminded of the many layers of reality and how our understanding of it is continually evolving. Shifting gears a bit towards another riveting concept closely related to parallel universes and the Mandela effect: time travel. Theories in physics suggest various mechanisms through which time travel could theoretically be possible. Astra, could you illuminate some of the current scientific theories on time travel for us?
Certainly, Luna. One of the most famous theories comes from Einstein's theory of general relativity, which allows for the possibility of warping spacetime under extreme gravitational forces. This could, theoretically, create a loop in spacetime known as a closed time-like curve, allowing for travel back and forth in time. However, the practicality of creating such conditions is a huge scientific and technological challenge.
It's like something straight out of science fiction, isn't it? Time loops, paradoxes, and the chance to alter history. These are themes that speculative fiction has been delving into for decades. Literature and films often ponder the ethics and consequences of time travel, offering a narrative playground for these scientific concepts. Indeed, Orion. And speaking of paradoxes, the grandfather paradox is a popular thought experiment in discussions about time travel. Astra, how does this paradox challenge the concept of traveling back in time?
The grandfather paradox poses a logical problem. If a person were to travel back in time and prevent their grandfather from meeting their grandmother, they would never be born, and thus could not have traveled back in time. It highlights fundamental questions about cause and effect and whether the past is mutable or fixed. Some theories suggest that time travel to the past might lead to the creation of alternate timelines or parallel universes to resolve these paradoxes.
That's a perfect segue back to parallel universes. This notion of alternate timelines not only fascinates physicists, but also fires up the imagination of writers and creators. The idea that each decision spawns a new universe is a compelling narrative device, allowing for endless exploration of what if scenarios. It does seem like time travel theories in physics open up a whole universe of questions about reality, identity, and the fabric of the cosmos. Whether these theories could one day prove to be a gateway to parallel universes, or whether they remain in the realm of speculative thought, the journey of exploration is undeniably thrilling. Speaking of thrilling journeys, let's pivot to a topic that often comes up in discussions about parallel universes and time travel: black holes and wormholes. Astra, how do these cosmic phenomena tie into the idea of connecting different universes?
Black holes are perhaps one of the most mysterious and intriguing objects in our universe. According to general relativity, the immense gravity of a black hole can warp spacetime to such an extent that it might theoretically create a bridge or wormhole to another universe or a distant part of our own universe. These theoretical passages are often called Einstein-Rosen bridges.
It sounds like something straight out of a speculative fiction novel, where characters jump through portals in space to emerge in distant galaxies or alternate realities. It's fascinating to think that these concepts have a basis in real scientific theory.
Indeed, Orion. However, it's worth noting that while wormholes are a solution to the equations of general relativity, actually traversing one would involve overcoming monumental technical challenges, not to mention the theoretical challenge of preventing the wormhole from collapsing.
That brings up an interesting point. In literature and movies, traversing these cosmic bridges seems instantaneous. But Astra, what does current science say about the feasibility of using these wormholes for inter-universal travel?
Current physics suggests that while wormholes could theoretically connect two distinct points in spacetime, keeping them stable and navigable requires forms of matter and energy that we have yet to understand or discover, such as exotic matter with negative energy density. These requirements make the practical creation or use of a wormhole for travel highly speculative at this stage.
So, while we're not quite at the point of hopping between universes or traveling through time, the concepts of black holes and wormholes fuel both scientific inquiry and creativity in the arts. They challenge us to think beyond the confines of our universe and imagine what might be possible in the vast cosmos. Speaking of challenging our understanding of reality and the cosmos, let's delve into one of the most famous thought experiments that intersects quantum mechanics with the idea of parallel universes, Schrödinger's cat. Astra, could you explain the basics of this experiment for our listeners?
Of course, Luna. Schrödinger's cat is a thought experiment conceived by physicist Erwin Schrödinger in 1935. It illustrates what he saw as the problem of the Copenhagen interpretation of quantum mechanics applied to everyday objects. The scenario presents a cat that might be alive or dead, depending on an earlier random event. Until the box is opened, the cat is considered both alive and dead at the same time, suggesting the cat exists in a state of superposition.
This thought experiment has been a rich source of inspiration in speculative fiction, serving as a metaphor for the unknown outcomes and parallel possibilities that define our existence. It's fascinating how a concept from quantum mechanics has permeated our culture, pushing us to question the nature of reality and the many worlds that might exist alongside our own. Indeed, Orion. The implications of Schrödinger's cat go beyond the quantum level, prompting debates about the very fabric of reality. Astra, how does this thought experiment relate to the idea of parallel worlds?
The concept of superposition, and by extension Schrödinger's cat, ties closely to the many worlds interpretation of quantum mechanics proposed by Hugh Everett. This interpretation suggests that all possible outcomes of quantum measurements do actually occur, but in many separate parallel universes. In the context of Schrödinger's cat, this would mean that there is a universe where the cat is alive and another where it is dead. It brings a compelling layer to our discussion on parallel worlds, suggesting that every quantum event branches the universe into a myriad of possible outcomes.
So, in a way, stories that explore alternate realities and parallel universes are not just flights of fancy, but are grounded in serious scientific thought experiments and theories. It's a beautiful reminder of how science and fiction fuel each other's imagination, pushing the boundaries of what we believe is possible. Absolutely, Orion and Astra. Today's journey through the concepts of the multiverse, the Mandela effect, time travel, and the intriguing Schrödinger's cat thought experiment highlights the endless possibilities that lie at the intersection of physics, philosophy, and fiction. As we continue to explore these ideas, both in scientific research and narrative exploration, we open our minds to the vastness of the cosmos and the myriad worlds that might exist beyond our own. Thank you, Astra and Orion, for shedding light on these fascinating topics, and to our listeners for joining us on this journey through the universe next door. Let's keep questioning, exploring, and imagining the myriad possibilities that the cosmos holds. Until next time, keep looking up and wondering about the universe next door. Goodbye.